Okay, so the assembly for P6-11 is not going to be real in-depth. We'll just bring up our assembly. It should jump right into the insert component. No, guess I still have that turned off. So let's go insert component. We'll browse. I'll bring in the threaded body, and we'll just let it go that way. And then we can insert components again. Bring in the screw. Line those up. Oh, and my first indication, oh, it fixed both of those. So, not, I guess I just clicked the check box automatically. But if you do get one fixed, just right click and float it. And then notice that, well, let's see what we need here. We have the 709, so we're an inch. Okay, that makes sense. That's the 18 millimeter. What I was going to say is I thought that the 22 millimeters, but for relief, yeah, that should be okay. All right, so we're going to make those concentric. If not, um, if this was the wrong size, I'd go back and check the minor diameter. All right, so let's go to looking at this with one of these guys. That was the hide. We want to go to the next one. And the body, we will put in hidden lines visible. So as that makes the intersection, we kind of see what's going on with the geometry. So we're not going quite to the bottom, which is good because said if we do tap this, and tapping is going to be sort of what material. I mean, I didn't see anything called out, but I've been doing a lot of 304 and 316 stainless lately. This is aluminum. I'm a lot less concerned about it, but otherwise the geometry becomes a little bit of a challenge. Oh, and this one I put it the same size. So we need to make an adjustment to the second. So if I double click on that, even though it is in the point for, it is in inches, I can type in the 41.5 millimeters and hit enter and then rebuild. So part of our iterative process is that we're making adjustments, we're finding out any oversights and mistakes we might have made along the way. So those look lined up. Again, the M6 going into a 5 millimeter thread, we're going to see some interference. So maybe we make those, they called them an M6 by 10. That still seems like it's going to be a little deep, but let's go into the toolbox. So we're jumping into the library. And in the design library, we can go toolbox, tell it to add in now. We're looking for ANSI metric, bolts and screws. And we would like a hex head. Doesn't call out specifically, so probably not the heavy. We need something that will be small enough. And the ANSI B18.2.3, 0.5 or 0.1. Well, at some point we have to pick one, so let's go with that route. Since it says there is not a matching size, let's see what the smallest one is, because that usually, okay, it picked up an M6. That usually is the deciding factor, is can I get one out of that standard? And the smallest is by 10. All right, so this didn't jump to my geometry, and like that one did, so I didn't get it lined up. But if I can, I'm going to look for the stack of marshmallows or the concentracy and let it do its automatic relation. All right, so that is the interface. If we wanted that to go into the geometry, the M5 screw would be enough smaller that I wouldn't have really any issue with it going in and contacting. Maybe there's an O-ring in there, and if we were to do an O-ring and a seal, maybe that comes in and just pushes on the O-ring and provides some resistance. All right, so there's some different mechanical options there. let's go ahead and select Control Select. We're going to go concentric, and I'm going to flip the mate alignment, and then we need to get that out of there. All right, and then for setting this, I could go tangent, because really that's going to be where, very closely it's going to contact. So through the wireframe, I can pick those, and we go to those faces, and I can say, okay, put that at tangent. And the other option then would be, I'm pretty close there. This isn't super critical as to our geometry, so having something easy to pick. But if we wanted to go with that 20 millimeter, then let's see, my mates did not show up, so we'll go distance. And we had 10 millimeters. Oh, that was 22 millimeters, so 11. Okay, so that puts us to the outside. So if we did want to control the outside, just guessing, not knowing what this really does, we're kind of stuck with maybe this is a mount, maybe this is a port. There's a couple of different ways to approach it. All right, so looking at the face, let's move those over, and I want to go with the distance again. Let's go 1 millimeter. Oh, 1 millimeter, and we'll go ahead and accept. All right, so that puts it pretty close. Everything looks centered. It gives us our chance to make some decisions. All right, so for the view, let's go ahead and put that one back into default. And we'll make sure to save this as the, I don't think it gave us just an exploded assembly. So I'm gonna make this into a valve of some kind. So let's do this. Oh, and no, we do not need to save the hex. So we can either uncheck that or do not save, so it takes it out of the list. And whatever you want to call this, we'll name it as the valve. While we're here, we'll go straight into the exploded view. We're not worried about the auto spacing because it is pretty much just going to be these items. So 3-inch should be enough, and then done. And oh, I guess I added that one to the group. No. Oh, got them both. All right, well, let's try that again. All right, make sure that all right, got to make sure in the list that I didn't already. All right, so there is only the one. And done. And then we pick the next one and we drag it out a little ways and we see what we got. 1 inch would be fine. And done. And then the last one. And done. All right, so that gives us our shape. Okay, so then I'll go ahead and illustrate the assembly cut, and I'm going to use this in the drawing as a cutaway view of the face, so of the intersection. So if I go back to the exploded view, collapse it, and then let's go back to the design tree, and I'll just open up a sketch on the bottom. And we're going to draw, I don't know if it needs to be infinite length, but we'll make it long enough that if we needed it to cut through everything, it would. And we'll set that as the midpoint. And our length, we can go like 3 inches. It's not that it matters. All right, so back into the isometric, selecting that sketch, we have assembly features, and I want to do an extruded cut, but I only want to cut the threaded body. So selected components, and we're going to turn off the auto select so that it gives us the geometry that we want, and then we're going to go through all. So the first arrow goes this way, and the arrow that does the flip side to cut does that one. All right, so having done that, I did not set this up for a configuration, so the best way to manage this is to add a configuration, and the configuration name is, we'll just call it sliced. And what I want to do is we're double checking, we're in the default, we need to suppress. So depends on which way you want to work with that, but that gets us the geometry. Is that necessary? No, but it does show some of the other geometry. So the other thing I could have done is if I wanted a quarter section, I could have just brought the lines in at a 90-degree and it would just remove partial, but splitting it, slicing it in half is not too big of a deal. All right, so if you've made your own template, then would recommend that you use it. And if not, then the A landscape's going to be fine. And we'll go to our view palette, grab the valve, and I would like the isometric exploded first so that I can go right into the to the tables, go to the bill of materials, and if I have a favorite, no, it jumped out. I need to put mine that I created a while back in there. So there is the bill of materials SLDBOM, and we want to add that table. So I haven't put any part numbers in. Do we have any part numbers? Apparently we do not have part numbers, so you can make up whatever part numbers you would like. So let's drag these out a little bit. Probably should zoom up just a bit. All right, so that one should be okay. And when we're reading the toolbox geometry, hex cap screw, if it was a socket head cap screw, we would see the SHCS. If it was a flat head, we would see FH. If it was button head, we would see BH. Okay, so we have all of those as parts of our deciphering what's going on with these screw geometries. Next thing is the auto balloon, and we'll line those up, see how it looks to the left. And can't say it's too bad, but we might as well see if we can bring that one back. See if it'll let me have the grip. And we'll drag back to that point. All right, so if it goes to the question mark, it's just telling me I missed. Try again. And we can bring those a little bit closer. Oh, you can also drag the magnet line to control the spacing. All right, so let's go back into our view palette. We'll bring in the standard isometric, and this is where I would want to pick my configuration as the sliced. All right, so now we can see a little bit on the internal size-wise. That was 1/2. Let's switch it over to a custom, and we'll go 1:1. All right, so not too crazy. Let's go ahead and save this as the valve. I'm not going to worry about the properties on this one, or as much about the properties on this one. The valve, the default, those items have made it in there. Next, bring in duplicate names. I think the block is the the first angle projection view, or third angle projection view. So, and that looks like I reversed it, so it's not correct anyway. So I guess I get to modify that one. All right, so not sure how that happened. Insert the from the view palette. We'll go pick whatever other one is open. We'll just bring in the front plane. I don't like the orientation, so if I drop that one and that one, then we can accept it. But I really want to turn this 90 degrees. So let's go 90, see what we get, apply it. And yes, and what it's warning is that you may lose dimensions. Last time I tried it, it didn't dump everything, but it's always a concern. If you know you need to rotate, do it sooner than later, because once the dimensions are in, it's kind of hit and miss as to if it will dump all of the dimensions on you. All right, so I wanted a center line. Pick the view, go into the center line. If the view's not selected, you'll have to pick it again. That looks okay, so let's go stretch that out just a little bit. Yeah, it looks all right. All right, so for our geometries then, we want, and we're looking at the end here, so it's not as clear what's going on, but let's go with, and since we're in inches, we're going to see that size. Would like a chamfer dimension. So apparently picked that the wrong way. All right, and chamfers and radiuses, not a good idea to put 3 decimal places on it. It is not that critical, so works out to be about the 2 millimeter on the geometry, 0.94. And I think it makes a little more sense, although it's not as clear. It's always a concern that even though showing that as 3 times, yeah, it's always a challenge because even the M20 is going to be a little bit under that after we get through cutting the threads. So let's see what it looks like. We can always change it later. The diameter 0.591 for 15 millimeter. That looks a little bit crowded. So I usually would go baseline from the tip. So let's go 2 times. And realistically, let's go to a, oh, that was an inspection. I really wanted the reference. Okay, so giving this, maybe not both. All right, it did not toggle that one out for me. So the way I would look at this on the lathe is I'm going to touch off on that face and start doing my geometry to preferably the back sides. Now, if I left it at the 197, that this is not a critical groove, then going to these geometries, when I set up the grooving tool, I'm touching off here and I'm going to see that face and that width come over, and using a 5 millimeter grooving tool, I'm just going to peck it into it until it gets to that geometry. So if I'm not going to baseline all of those, then I really didn't need the reference. All right, so we need to see on our, let's see if the smart dimension will do it. I go to the cosmetic thread. No, it's still doing that one, so let's go to the whole call out. There we go. We'll try the whole call out anyway. 0.787, no. And I did not tell it to show that on the cosmetic thread, so it's not picking that up. So if that's the case, we could either override the dimension. I know I've gotten it to do that before, but it is. I went back to the 197. We'll try one more time. No, whole callout's not finding it. All right, so if that's the case, let's go with the smart dimension. There it is. I don't know why it wasn't highlighting, but it's always a little annoying when it does that. So the M20 by 2 thread gets called out. It's should be apparent, but for thread depth, then we may want to just measure for that geometry as a reference, 906. And then we can go in and add that as our geometry. So depth. And let's see, that was 197, so the thread depth on a 2 millimeter. Again, that's more for reference, but it says to overrun it into the geometry or up to next. All right, so it's just some choices that we have to make. Let's go into the next. So when I made the template video and named that as a block, that was one I was looking for as the issue. So we'll get that turned off. All right, so the threaded. Let's go with the threaded. We'll look at it from the top. Drag that in. We'll go to the isometric and accept. So this is 1:1. It's not going to be too bad. We'll go to a custom scale and shrink that down a little bit. Ideally, we would say isometric, half scale, something along those lines. But most of the time, it's apparent what's going on there. So go into the drawing, and I'm looking for a section view, and we'll place that on the origin and drag it out. So what this isn't going to do is show me the other lines. So, and we would lose. Let's see if we reverse that. If I flip the direction, do I get both of them? No, I'm going to lose one or the other of doing that. So we would need to decide: do I want the other view, and carry that through. So as our 3-view drawing goes, that makes more sense, but I think we're going to have to go, let's use a smaller or user-defined, and we'll let it go 3/4. And then let's bring out one more projected view. All right, so that does help us a little bit. One of the things I've often changed is the font for the sections. This always seems a little weird to me, how big that is and then how small that is. So I usually just make those the section the same size as the label. All right, so back into our smart dimension. We'll pick the first hole location. We need the hole callout. And we'll just go ahead and duplicate the whole callout rather than trying to set it twice. Oh, I picked that one up again. So let's flip the direction, even though I don't like the way that is going. Interesting. So let's make some adjustments. We'll go ahead and go that way. Probably easier just to bring in the next projected view. So one on that side, one on that side. And no, it did it to me again. It put that one over there. Well, I've done this before. Now let's just undo a couple of those. So even though I'm not a fan of the dimensioning in view, I do remember running into this before though. So let's go back to the parent view and we're going to make all of these through. Now if we tried to make that a broken out section, that would probably work. But it is strange that it's not giving me not giving me that that geometry the way that I want it. All right, so for now, I'm not fond of this as a solution because dimensioning to hidden objects is not a good plan, but it does get my my geometry in place. All right, let's keep going though. So from the face, and then we'll go to the depth. All right, so baseline dimensioning, when I go to inspect this, these are all direct measurements rather than having to do math or stack up, so this is going to be preferable. I did the 2 times on that one, so we should be able to go that way. And the only difference is if I did the whole call out bit. A lot of times when that geometry is so close, it's hard to tell which one it's going to. So maybe that will help with the geometry. So let's see, is it getting? It did find the whole call out on that one. So the 709. And the 1.102 is from the face. So if we go into our geometry settings, then I can find those 2 numbers and just set those to 2 decimal places. All right, so again, this one's a little strange. I have to come up with a better way to do that, but that gets us started. So we have that geometry, we have our drawing, and we go ahead and save it, and that'll be good for now.